Okay, so let's jump into an example and see how to find the x-intercepts of a polynomial. So we're taking this function here, f of x. So how do I find the zeros of this function? Well, I know there can be at most 4 zeros because the degree of this function is 4, but there could be fewer. So let's take a look. Like our quadratic functions, we want to try to factor this polynomial. Now, this is kind of easier said than done. We can't use our normal factorization by parentheses we might use for the quadratic functions, or we can't use the quadratic formula to do this either. Well, there are a couple of different ways. There is factoring by grouping, there is synthetic division, and there is long division. Factoring by grouping doesn't always work for all polynomials, so let's skip that for now. I prefer long division over synthetic division, so let's try that out today, but in a future video, we'll go over the basics of synthetic division. To start my long division, I first need to make an educated guess about what my first factor is going to be. In order to do that, I take the factors of my constant term, in this case -6, and divide that by the factors in my leading coefficient, in this case +1. Now, fortunately, the factors of +1 are just +1 and -1, so that's easy. And the factors of -6 are ±1, ±2, ±3, and ±6. So that leaves me with a slew of different possibilities for my first factor. ±1, ±2, ±3, ±6. This gives me 8 different factors that I can try. But I like to try the easiest ones first so that if I get the right answer, I don't need to try all the hard things. And if I don't get the right answer, at least I didn't spend too much time on the wrong answer. So let's try 1 as our first factor. So I take my function and I divide it by x minus 1. So what I do is write in the quotient here, whatever times x is equal to the leading term in my polynomial. I then subtract that from the polynomial. I keep doing this until I run out of terms in the polynomial. If the remainder is 0, then I know my factor that I chose, in this case x minus 1, is a factor of the function. If the remainder is something that's not equal to 0, this factor is not a factor of the function and I need to start over. But fortunately, x minus 1 is a factor of this function, which means now that I can start factoring this cubic polynomial that I have as my quotient. I'm now left with this factorization of my original function. But now I can factor this new cubic function down to a quadratic function. Let's do that now with the factor x minus 2. If I plug that into my long division, I do more steps by multiplying the quotient times x to get my leading term in the cubic function. And I get this result where again the remainder is 0, so I know that x minus 2 is a factor of my function. Now I'm left with this factored form of my function, x minus 1 times x minus 2 times this new quadratic function. Now the quadratic factor, we don't need to do any more long division. We can use normal rules of factoring, and this quadratic function factors nicely. Now I'm left with this series of linear factors of my polynomial, x minus 1 times x minus 2 times x plus 3 times x minus 1. Now I'm going to group the x minus 1s together so we get f of x is equal to x minus 1 squared times x minus 2 times x plus 3. Now solving this, setting my function equal to 0 to find the x-intercepts, I find that my x-intercepts are x is equal to 1, x is equal to 2, and x is equal to -3. Now what does this mean graphically? Because 2 and -3 are unique roots, that's where the function is going to cross the x-axis. Because the factor x minus 1 has even degeneracy, at x is equal to 1, the function is going to bounce off the x-axis at that point. And now finally, because my leading coefficient is positive, that means that the function is going to come in from the top left-hand corner of the graph and exit via the top right corner of the graph. In summary, the function looks like this. If you have any questions, leave them in the comments below, along with any suggestions you have for future episodes of How'd You Get That. Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see you in the next problem.